Again, two-step algebra problem. How do you move a -3? So we have, what, 28 is 8x. Divided by 8, what'd you get? Yep. It is completely, totally fine. You're going to see decimals from time to time, guys. You really will. Don't freak out. Oh my God, I did something wrong. Blah. It's going to happen. Okay. 72 and the f plus 30, are those opposite one another? No, they're on the same side, so they have to add up to equal how much?
180.
180. So there's two ways you can go about doing that. Find the supplement of 72 right away, or just set them up and add them together and set it equal to 180. Either way is fine. You go this route, you subtract out the 102, you're left with?
78.
There you go. And I know I wrote F, I just, old habits of just using X's and Y's all the time, that's all. Okay. Excuse me. Not so bad, right? The more of the goofy stuff winds up being then when you start seeing things with diagonals. It's not just because, it's not that it's difficult, it's just sometimes it's hard to see what parts are going to what, that's all. Normally what happens when you see diagonals, usually they put the parts that are on the same diagonal, like either above each part or below each part, if that makes any sense. So see how the 9 and the 2n are on the same side, and you're like above that one diagonal there? That's where we would say that those two are together. Normally they don't write the 9 down here, just so you guys see how that goes. And
Together as in equal to 180?
do segments equal to 180? No. Diagonals do what to each other? It's on the board, you just looked at it. What does that mean?
I don't know, like cross?
Yes, they cross, but what does bisecting mean? It's from first semester.
I don't know, right?
What's that? Right, so that means each part is what? Yeah, they're equal to each other, they're cut in half. Bisect means you cut it in half, okay? You can't forget those terms, we use them over and over again. So again, it's not that it's gonna be crazy. You get 5, okay? Really fast stuff to set up. Add 1, divide by 2. What gets goofy is when you start to get to the big picture style problems. And I know we've discussed this before. Whenever you get a diagram that has multiple parts to it, you never want to read the questions themselves. What you want to do is go right to the diagram. What I want to look at here is the diagram that's on the back of this page. I think it starts about number 21 here. And use that as kind of like an idea of, I just figured I'd use a couple of these pictures. I don't have to keep trying to draw pictures because, you know, not everybody's artistic as I am.
Do you say Target or Target?
Depends on what day it is. Tuesdays it's Target. Everything else is Target.
Wait, we're here? Yes.
What?
Did we do a job? Did you do that?
Yeah. I got one left up for me.
It was just like, oh, where?
She can't say. I'll see that. Is there a sophomore?
So what I mean by this is whenever you have diagram pictures that you have more parts than, or more questions to go off of one diagram, just like we did first semester, anytime that you have something like that, don't read the questions. Never do that. You'll get lost in the questions, you're going to use the wrong thing for the wrong part or something along those lines. But what you do here is you want to just start filling in the blanks. Okay? Nigel, what did I say? You got lucky. Come on, man, you gotta stop talking. Okay. Now, going back to what we already know. In a parallelogram, you know what about the opposite sides? They're congruent. So, if ij is 10, what's hk? 10. Okay. Which means hi is what?
16.
Okay. Which means hg is what?
Whatever you want.
It has to be what? 8. It has to be 8. Because they bisect each other, which means those two chunks have to be the same. Okay. Same deal with kg. What does that have to be? 7. Okay. From here, you could actually find the rest of the angles. Okay. Every one of them. Takes a little bit of work, but you can do that. One of the things I want you to see, though, is right off the bat, if this angle here is 84, what does this whole angle have to be? Are those two next to each other, or are they opposite one another? So if they're next to each other, what do they have to be?
120.
Yeah, they have to be supplementary. So what's the supplement to 84? 96, good. That means this whole chunk is 96. If the whole chunk is 96, what's left over for there? And you get that. You okay with that? And then you fall back to what you remember from parallel lines and transversals. If you have two parallel lines that are cut by a transversal, if this angle is 28, what does this angle up here have to be? 28, because they're on opposite sides of the transversal between the two lines. You okay with that? Alternate interior. Isn't that exactly what you have here? If you go through
Precisely.
two parallel lines, transversal. So this is 28. What's that?
28.
28. What's on the other side? 68. Because the opposite angles have to be the same. So far, so good? Now, look what happens here. Oops. Actually, let me just draw this on the outside here. If you go to the triangle that you have up top, I have triangle H. I have that, correct? I know that this is 8. What do I do? What could you do? You can do law of sines because you have the angle and its opposite. But the problem with this one is the way that this works. How do you remember what they said about side lengths for triangles? Do you remember that? The sum of two of them has to be greater than the third. What's that? Is that greater than 60?
No.
So technically, can I even make a triangle like this? But anyway, they weren't, it's fake, yeah, right? So this is the one time that a problem in a math book doesn't really work. But in theory, if we wanted to get crazy here, you could do a law of sines to figure out your missing angles here and here and go from that. Now, will that happen every day? No. Will it happen more often when we get into triangles that have right angles? Yes, because then you can use SOHCAHTOA stuff. So all that stuff will come back. The law of sines, law of cosine stuff doesn't come back very often, maybe once or twice, and that's about it. But I'm just saying that eventually, we're gonna get to parallelograms that these angles in the middle become right angles. And if that's the case, you could find your other angles by, subtracting from 180, or if you're missing all the interior side lengths, you could use, if this is a hypotenuse and an angle, you can use sine or cosine to find the other side lengths. That happens a lot, but that's still about a week or so away. Just letting you guys know that everything we've done, it does come back, and I know as much as you don't want it to, it does. Where's the other one? This one?
Wait, so how do you find,
What's that?
how do you find KIE?
Technically, we can't because it doesn't really make a triangle. So,
Oh, that's what the whole like.
yeah. But I'm saying that eventually we will be able to. I just wanted to remind you that you could use law of sines to do it, but since 8 plus 7 is not bigger than 16, this technically doesn't even exist, even though it's there. I know, the book. They didn't call me to proofread. I probably would have forgotten it anyway, or wouldn't have done it.
Would you have liked that job, to proofread a whole math book?
Hell no. No. I can emphatically say no. There's no way. You couldn't pay me enough to sit there and proofread a math
Do you have
book.
to do like every single problem?
Yeah.
Sure it works.
You would, in
You proofread our tests.
well, yeah, but it's different because I know what I don't know.
Could you make it, I guess?
Could I do it?
No, because you make our tests, so.
The other thing I want to show you here real quick is the next question, 29. The measure of one interior angle of a parallelogram is twice the measure of another. Find the measure of each. The measure of one angle is twice the measure of the other. Now, in a parallelogram, how many different angle measurements are there? Two of them. Okay. So if I say this one is x, this one down here has to be x because opposite angles are the same. Now, if one angle is twice the other, what would the other angle be? Twice this one, so how do you write that? 2x. You would do that. Now, there's two ways of going about doing this. One of the ways is that how many degrees are in parallelogram? 360, because there's 4 sides. You can do that and it'll work. Or, what do you know about the two angles when they're next to each other? What do they have to add up to equal? 180. So what's x and 2x? And that has to equal 180. So divide 180 by 3, what do you get? And the other angle is? There you go. You can do stuff like that. It actually comes up quite often where they set up very simple problems like this via algebra. Look at the next one. One angle of a parallelogram is 30 degrees more than the other. So if one angle is 30 degrees more, so I want you to think of it this way. Again, we've got the parallelogram. If you pick one angle, and then the, bless you, if the other, what does it mean when it says is? What does that mean in math? Equals. So if one angle is 30 degrees more than the other, what would you say? If one of them's x, what's the other one? If one angle is 30 degrees more than the other, if one angle is x, what's the other angle? There you go. Does that make sense? Because again, knowing that in a parallelogram, opposite angles are the same, if they're next to each other, they're always going to add up to equal how much? Really big. So if I do that, I get 2x plus 30 is 180. And you're back to another very fast two-step algebra problem. Subtract out by the 30. Then we have the 150. Cut 150 in half, and what do you get? So if one is 75, what's the other? 105, because you add 30 to it. Quick way to check, quick way to check, do those two add up to equal 180? Yeah. Then you're on the right track. That's the kind of things that you're able to do with parallelograms. You're able to go through and set up to see if they work. Okay? Let's try another one. On Monday? Yeah. Go for it.
Thanks.
Take a look at this one. It tells you that sometimes they use the symbol that looks like a, I don't know, lack of a better term, parallelogram, instead of using my fancy slashies with the ogram. But they say E, F, G, H. Are those all capital or lowercase letters? Which means those are labeling the, it's labeling the angles, okay? So what you want to do here is, well, draw a picture. Remember when we drew triangles, if we labeled out the vertices, you just pick any vertex and just walk your way around it. The exact same thing here, guys. You do the same thing. Doesn't matter where you start. You just go around the diagram, just like before. Excuse me. And now it's a matter of writing out how you set this up. Now, yes, there are other ways of shortcutting this, but I know that in the coming days or so, things could get a little bit more complicated. So if I show you guys a way that might take a minute longer, not really a minute, but might take a couple of seconds longer to do, it's going to be easier in the long run to do it that way. So if it says that angle G, oops, let me move this over. If it says that angle G is 25 degrees less than H, that means I would write it as this. I'm going to do it without the angle sign. Is that okay? Mm-hmm. G is 25 less than H. Is it 25 minus H or H minus 25? If you look at the diagram, G and H are next to each other, which means they have to add up to equal how much? 80. By writing it out this way, I'm creating a system of equations. Last year in algebra, you guys had systems of equations where you would use substitution, linear combination, some of those methods to solve for one variable at a time. Here, I have G by itself, which means in the second equation, anywhere I see G, what do I put? Exactly. What's H plus H? And once again, you're setting yourself up for a very fast two-step equation. Okay. What do you do first? Oh. And then you cut it in half. And what do you get? So if that's 102.5, what do I do to that to figure out G? Very good. And what do you get for G then? You get 77.5. If you add those two together, what do you get? Well, there you go. It sounds like, I mean, a lot of these things you can be able to figure out rather quickly if you work your way through it thinking-wise. But if you fall back to the idea of setting up that algebra problem of a system of equations, it'll work cleaner. Does it take a second longer? Yeah. But does it force you to substitute incorrectly? Yeah. Okay. That's what we're looking at doing here, guys. That's what we're looking at doing. Same idea, try that. write it out as a system. I know that you can probably figure it out in your head, but they're not always that quick and painless. So it says W is 50 more than X. They're next to each other, which means they have to add up to equal how much? So we use that little substitution step again. And what's half of 130? So if X is 65, W is very quick two-step equation stuff you guys are going to make yourselves set up here. Okay, there's no real craziness yet. Don't get me wrong, it does come up eventually, but if you continue to use the very quick system, it's going to be a lot easier on you. Right? It'll be a lot easier. Those are really crazy. All right. Let's do this. I'll give you guys some stuff. We'll get the crazier stuff tomorrow. I already put the numbers on the calendar. Let me pull them up here for you guys. I got them all cut.
No one asked me if I got my
I noticed you got your
You didn't say it.
I said you were missed. Well, what time did you get up?
About 9 minutes. Do these, please. Okay. If you give me a second, I will pull up the first handful of them and put them on the board. No, that was just the one. I was going to do different ones off there, and I changed my mind. So it was just for the one problem, really.
Look about the braid. Well, this was like snapped off. I'm scared of the future of this girl.
Gnat in here.
How do libraries make money?
That's a good question.
Donations and book fees.
Wait, what was the last number? 30 through what? I was on 25 and I was like, wait, that doesn't make sense. I wrote 23
There you go. You got the first handful of them that are up there. You guys can go ahead and get started, please.